this is your first Karamba tutorial. So when I want to analyze my geometry using Karamba, the first thing I do is that I set my Rhino model in meters. I then create ideally a parametric geometry inside Grasshopper. In this case, I will make a very simple surface that is 1 meter long and 0.2 meters wide. So it makes a stripe. It's important to keep in mind that these values of length are in meters, because this is what Karamba understands as length units. So I will keep this surface like that and mesh it using the component of Karamba that is pretty good. I have to adapt the resolution of the mesh so that I have a good discretization for the length and the dimensions that I have. So let's keep it like this. And you can also change these parameters and make it smoother. It's in general important to have same length edges for the structural analysis. Now I can assign properties and characteristics to this surface. And I will start with the material. We will do this example with poplar wood. So here we would need to put the right values for that. Sorry. Also, it's important here to keep the right units, the ones that Karamba is asking, and they're written here. This is very important when you're changing the material that you have. I continue with the strength, and then last value to make it work. So these are the values for poplar wood. You can use them to test your ideas, but you should pay attention that if you're making a paper model that you want to test in Karamba and you want to model it in Rhino, so you have it with different dimensions, in a different scale, then you have to put the right materials here, the paper properties. So next step is to put a cross section. In this case is the thickness of the surface. So I say shell constant and a small plate thickness. You can start with 0.5 centimeters. And now I can make my finite elements that are going to be used for the structural calculation. I assign cross-section, I assign material to cross-section, and I will give it a name. It's many times useful, especially when you have a more complicated setup. Next step is to apply support conditions. So I will try to find the four corners of this surface. I will ask for the endpoints. And here we go. And just simply support them. Now I will make already the model assemble. I will put the different properties that I created, and I will already ask for the model view to get an idea of what I have done so far and fix the visualization scale that I have. In tags you can also visualize different information. I can show the name that we created. And to run the structural analysis, I need to apply load. And I will start with the gravity load. Put it in the assembly. And then run my calculation. So here you can get the first information about the displacement, 0.3 centimeters, which is quite good, and it's the maximum displacement of your system. So this is pretty small, this is why it's pretty good. And then you can see more results in this component. Here, for example, you visualize the displacement, and you can put a legend so that you can read the values in which your colors correspond. Sorry. Like this. Another indication that your system is stable and stiff and that your material doesn't break is to check the utilization. Again, in this example, it's quite low. So what you can start doing is change the parameters. For example, make a strip that is twice as big or even more. You will very quickly understand how the displacement value will tell you when what you have doesn't work. So here, for example, I need a much stronger material, a higher thickness in that case. Changing the other direction doesn't really affect the result, as you can see. So this is it. You can start testing your own ideas using paper. Don't forget to change your material to the paper properties.